Hello everyone, welcome back. This is a Calculus 2. In this video, we are going to talk about 2.9, calculus of the hyperbolic functions. So a little bit of background, what the hyperbolic function look like. So here we go. So actually you learn hyperbolic function in pre-calculus. So in calculus 2, we've been dealing with integral, right? It's a little bit thick. So we have to take the integral to find out the area, volume, whatever. It could be a lot of, things. So by using integral, you can find out the area, volume, arc length, surface area, force, what else? We also can find out many, physics concept by using integral. And then you've been dealing with so many different type of functions. So here we know how to take the integral with the linear function, quadratic function, trigonometric function, composite function. So we talked about, a variety of function and how to take the integral in calculus 2 so far. Now in 2.9, what we're going to do, what if I have hyperbolic function, right? And how would you be able to take the integral? So in this unit, we're going to talk about hyperbolic function. Maybe some of you guys forgot what the hyperbolic function. So let me write down the definition of the hyperbolic function. So hyperbolic function is a very unique function because it is going to be defined in terms of certain combination of e to the x and e to the negative x. By combining, those following function, e to the x, e to the negative x, we're gonna find out a couple of hyperbolic function. So let's say you can think about, let's say f of x equal to e to the x, and let's say g of x equal to e to the negative x. You might be able to combine them by adding or subtracting. Or we can have 1 over 2 e to the x, and then g of x, let's say 1 over 2 e to the x. You might be, combine them by adding or subtract. So there are a couple of, e to the x function form, right? So that the thing is hyperbolic function, especially when you're combining 1 over 2 e to the x and 1 over 2 e to the negative x. If you combine those two functions, you're going to find out a couple hyperbolic function, and it's going to be defined cosh function and sine h function. So let me write down one more time. So again, hyperbolic function, is defined in terms of certain combination of e to the x and e to the negative x, such that more specifically, you can adding 1 over 2 e to the x plus 1 over 2 e to the x and 1 over 2 e to the x minus 1 over 2 e to the x. We're going to talk about those two hyperbolic function in 2.9 unit. Okay, so let me write down more a couple information. So hyperbolic function, we are going to combine 1 over 2. So again, hyperbolic function, you are going to combine, let's say 1 over 2 e to the x. This is one of the function, and another function 1 over 2 e to the negative x. You can, excuse me, you can adding them. So summation f of x plus g of x. So in this case, we have a 1 over 2 e to the x plus 1 over 2 e to the negative x. You have a common denominator, so this is going to be e to the x plus e to the negative x over 2. We call this function as a cosh function. So this is cosh x. And then specifically, you can imagine 1 over 2 e to the x, it's going to be increasing function. And then 1 over 2 e to the negative x, it is going to be the decreasing function because of the negative exponent. You are actually adding them. So the Cauchy function, if you graph it, it is going to be something like this. So this is going to be Cauchy function graph. Okay, so the first case, when you're adding them, those are two functions, right? F of x is a given, g of x is 1 over 2 e to the x. When you're combining those certain e to the x and negative e to the x, we call this is a Cauchy function, and that is the graph. And then Cauchy is going to be that function. And now we have another one. You can actually subtract them as well. Subtract. So f of x minus g of x. So it is going to be 1 over 2 e to the x minus 1 over 2 e to the negative x. So if you simplify, same common denominator, e to the x minus e to the negative x, we call this is sine h function. This is sine hx. And then again, we know that 1 over 2x, I'm going to copy, and we are subtracting them. So the graph of the sine h is going to be symmetry. One is going up, then one is going down. Okay, this is the sine hx graph. So we call these two are type under the hyperbolic function. There are a couple more hyperbolic functions, but in 2.9, we're going to focus on Cauchy and sine h function as a hyperbolic functions. Okay, so that's the definition of the hyperbolic function. And then what we're going to do, we are going to see how to take the integral of those two hyperbolic functions. Does it make sense to you? Yes. So you got that. You just understood what the hyperbolic function looked like. We are going to deal with Cauchy and sine h in 2.9 and learn how to take that integral. Okay. So let me go down slowly. We got the concept slowly here. So one more time, I'm going to show you Cauchy function first. So the Cauchy function graph is going to be looks like this because we are adding 1 over 2 e to the x plus 1 over 2 negative x. We are adding to, certain e to the x and e to the negative x. And then if you are actually look at the characteristic of the Cauchy function, here we go. I'm going to write it. Cauchy function is the even function. Okay. What does it mean, even function? The outcomes of the function are the same. So one of the characteristics of the Cauchy function, here we go. If you are plugging in x, okay, into the as an input, so Cauchy x, if you're plugging in x, so it is going to be e to the x plus e to the negative x over 2. So this is when x equal to x. But let me change the input as a negative x. So what happened? The x is going to be negative x, and negative x, if you're plugging in negative x into x, is going to be positive x. So it's going to be just change the sign of the x. So if you're adding them, it's going to be e to the negative x plus e to the x over 2. So what I'm trying to convince you is, if you have a different sign of the input, what happened? These two are actually same. I just changed the order. So even function is that even though you're plugging in x equal to 1, let's say the outcome is a 3. Even though you're plugging in x equal to negative 1, the outcome is a positive 3. So they're same outcome. That's a characteristic of the even function. So that's what Cauchy function is following. Cauchy function is an even function. Although you're plugging in x or negative x, the outcomes are same. Okay, so this is the characteristic of the Cauchy function. Remember that it is adding. It is an even function because you're adding them. Okay, so that's the quotient function characteristic. And I want to look at the subtract case. What would be what other characteristic you're going to find out? So let's take a look at that. So we remember, if you are subtract those are two certain function, we call that as a sine h function. And I'm going to adding this quotient function. We just proved that it is even function because we just found out cosh x is equal to cosh with negative x. So let's take a look at the characteristic of the sine h function. Here we go. So sine h function, we know the graph is going to be looks like this, is symmetry. And then we are going to subtract 1 over 2 e to the x minus 1 over 2 e to the negative x. So you have sine h function. And then let's take a look at it. This is when x equal to x. If I combine it, this is e to the x minus e to the negative x. This is a sine h function. But now I'm going to change x as a negative x. So the positive x become negative x become positive x. So let's take a look at it, what you're going to get. So it's going to be this number. So now if I combine e to the negative x minus e to the positive x over 2, they are not equal. So this is the case. When x equal to negative x, what happened? The outcomes are same? Not really. E to the x minus e to the negative x, it's not equal to e to the negative x minus e to the x. So what I'm saying is they're not equal because it is odd function. So I'm going to write it here. E to the x minus e to the negative x over 2, it is the same as negative e to the negative x minus e to the x over 2. If you use a negative distributive property, they're going to be equal. So therefore, sine h function, they're not even. You're going to multiply negative in the front, so then they're going to be equal. So this is the characteristic of the sine h function. Sine h function is the odd function. So which means they have, if you're plugging in 2, you will get the positive outcome. If you're plugging in negative 2, you have a negative outcome. So the number is the same. The outcomes are same as a number, but the sign is a different. So that's why you have a negative. So you're going to plugging in x positive, you're going to plugging in negative x. The outcomes are not equal unless you multiply -1. So that it's an odd function characteristic. So sine h is the odd function because the outcomes of the function of the hyperbolic function have a different sign. Okay, so that's the odd function, sine h. So we subtract them. So this is the characteristic of the sine h function. So let me write that characteristic. So sine h function, we prove that it is odd function. What they mean? The sine h with the positive, sine h, sorry, I forgot the h, sine h with the positive x, sine h with the negative x, they're not equal, but you're gonna be equal if you multiply negative x. So that's the odd function characteristic. Okay, so we checked, you know, what the hyperbolic function look like, and then what their characteristic. So you can think about it when you heard about the hyperbolic function. Oh, I know this, right? So we're gonna keep checking, you know, a couple more characteristic, and I will show you how to take the integral. So let's keep going down slowly. So we check the characteristic, and then here, as I mentioned, there are a couple more hyperbolic functions such as the sine h, x, cos x, tangent hx, because it came from the trigonometric function. And then you can, you know, cos function, sec function, you know, cosecant h function. But in 2.9, we are going to only focus on sine h and cos h function. So remember, cos came from the summation between them. And then sine h came from the subtract between those two. So remember, we're going to deal with the quotient sine h only in this topic. Now the real problem we're going to deal with, how to take the derivative or integral this hyperbolic function. So let's take a look at down slowly. So this is exactly what I want to talk about it. So a little bit of background. We know how to take the derivative of exponential function. So if you remember, d over dx e to dx, everybody know it is e to dx. D over dx e to the nx, if you have some constant, it is a 1 over n e to dx. So for example, d over dx e to the negative x, you're going to flip over negative. So 1 over negative 1 is the same as a negative. So it'll be negative e to dx. So please remember the characteristic of the e to dx. So e to dx, you get e to dx, e to the negative x, you will get negative e to dx. So because of that reason, quotient sine h differentiation, it's going to be similar, okay? So one more time, cosh is a summation, sine h is a subtraction. I want to take the integral of the sine h function. So what are you guys going to do? We have this function, and then 1 over 2, you can bring it. So here, you're going to take this. So 1 over 2, so 1 over 2 d over dx, same as e to dx minus e to the negative x, correct? So now when you take the derivative of e to dx, what happened? Same as e to dx. When you take the derivative of the e to the negative x, that is going to be negative. So the negative with this change to positive. So you will get e to the x plus e to the negative x over 2. So what is that? This is the cosh function, isn't it? So therefore, when you take the derivative of sine h, you will get back cosh x function. Does it make sense to you? So think about it. This is a very understandable topic, correct? Same thing, when you're taking the derivative of cosh function, we know that it's e to the x plus e to the negative x over 2. So that means d over, you're going to take the 1 over 2 to the front, d over dx, e to the x plus e to the negative x, correct? And then you're going to take the derivative of each one. E to the x will be e to the x. E to the negative x will be negative e to the negative x. Exactly, that's the outcome. And then what happened? This is going to be what? This is sine h. So when you take the derivative of cosh x, it's going back to sine h. When you take the derivative of the sine h, it's going to be cosh x because of the characteristic of the exponential function. So you can find out this information in the derivative of the table as well. And this is the proof stuff. Okay, so calculus 1, they didn't actually talk about this, but in calculus 2, we are going to see both the differentiation and integral of sine h and cosh function. So that's what you need to know. Okay, sine gonna be cosh, cosh gonna be sine in terms of the differentiation. So therefore, now you can think about the integral, right? Integral is gonna be literally antiderivative. So let's take a look at it. So this is all the information you can find out in both calculus 1 and 2 table. Calculus 1 and 2, if you go to differentiation and integral table, you can find out the information. But again, we're going to focus on quotient sine. So quotient sine function looks like this. We just proved that. Take the derivative of the cosh, we got sine h. Derivative of the sine h, we got cosh. But then what does it mean? Antiderivative. This is the integral. If you take the integral of sine, you're going to go back to cosh, which makes sense. So integral sine h, you're going to get back cosh. And then integral of cosh, you will get back sine h. Very, very similar from the trigonometric function, sine and cosine function. So if I want to add one more thing, the tangent one is the same as sine over cosine. So that's why it is a sine h over cosh function. if you take the derivative, if you remember, we spent a long time to prove, the derivative of the tangent is going to be second square x. So same thing is happening. Derivative of the tangent h as a hyperbolic, you will get second hyperbolic second x function. And then the opposite is the integral. So you will get back the tangent. So these are not complicated formula. It's very understandable. So we're going to utilize cosh, sine, and tangent hyperbolic in 2.9 in calculus 2. Okay, so let's really do the problem. Okay, so we talked about the hyperbolic function and their characteristic and how to take the differentiation and integral both. Let's do the real problem. Are you guys ready? Ready? Take a look at the following example 1. So here, they want you to take the sine hyperbolic x to the second function. You're going to take the derivative. So check the structure. Number 1, this is a sine h function. What happened? X to the second function has been subbed. So you see the two functions. One is a sine h function. X to the second has been subbed. This is exactly chain rule. So you're going to take the 2 times of the differentiation. So d over dx sine h x second times d over dx second. So this is, outside. This is inside the chain rule. So what happened? When you take the differentiation of sine h, they're going to be what? Cosh. So it's going to be cosh x second, and x second, that's chain rule. This is going to be 2x. So therefore, the final answer 2x times cosh x second. Boom, 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 boom. We got it. You see that? You can take an integral or a differentiation, the hyperbolic function. So let's take a look at a couple more. I'm going to change the color. And I'm going to make a little bit smaller. So let's look at letter B. Same thing. You see the 2 functions going on. What happened? One is quadratic function, right? Something to second power. And Cauchy function has been subbed there. So this is another chain rule. So what are you guys going to do? You're going to take the derivative outside Cauchy x entire second. D over dx inside Cauchy x function. So one more time. This is outside. This is inside. So this is going to be, you're going to bring 2 to the front. So 2 Cauchy x, that's it, times Cauchy going to be sine hx. So if you're confused, I'm going to make a parenthesis. So that's the answer. 2 times Cauchy x times sine h. There we go. Gotcha. Getting better and better. So what last one? Same thing. This is what? I see 2 functions going on. Tangent h function, outside. X second has been inside. So you have to use chain rule. So d over dx tangent h x second outside. And then inside x second. So take a look at it. Outside. And then this is inside. So tangent h, if you take the derivative, we talked about it. It's going to be second square h and x second. And then x second will be 2x. So therefore, 2x times second hx. There we go. That's your final answer. So I hope you have a better confidence what we are doing. We understand what the hyperbolic function and how to take the differentiation so far. So next one, let's take an integral, the antiderivative. Let's take a look at it. So this is an integral, not differentiation. So I want to take the integral x times Cauchy x second power, 2 different functions. So think about it. This is a very, very similar what we did in the previous chapters. So definitely x second has been subbed. We know that Cauchy and then x second has been sub. So in terms of the integral, what happened? You're gonna use a u substitution because x second has been sub. So let u, I'm gonna use a u substitution, becomes x to the second. Take the derivative, 2x. So du will be 2x times the dx. Okay. I want to convert x times the dx in terms of the u variable. So all you need to do from here, you're going to divide it by 2. So du over 2, 2 divided by 2, 1. So x times the dx. So we found out x times the dx, that is a 1 over 2 du. So now this one, integral, we have cos u, x second is a u, and then x times dx, that is b, 1 over 2 du. So I can bring 1 over 2 to the front. So cos u du, and what happened? We know cos, if you take the integral, it's going back to sine h u plus c. And I'm going to go back to the x variable. So 1 over 2 sine h u is going to be x to the second. So that's your final answer. We just took the integral. Yeah. So it's not that challenging concept. We've been practicing how to take the integral and differentiation. So you got this. Okay, we're just dealing with the different type of function, hyperbolic function here. So let's take a look at one more, the bottom. Here we go, tangent. So tangent, we know it's the same as go up. Tangent is the same as the sine h of a cos. So I'm going to convert it. So note, tangent hx is the same as sine hx over cos x. So it's going to be integral sine hx over cos x. So we are going to take the integral. And do you remember what is that? The u substitution, the denominator will be the u. So we're going to use the same strategy. So you can take a look at, let u cos x, correct? So therefore du over dx, because you can think about it, it is the same as sine x times cos x inverse 1, right? So it's the same thing. So that cos is being sub. So you're going to set u equal to denominator. So therefore, if you take the derivative of the cos, we know, this is a sine h. So du equal to sine h times dx. That's all I need. I have sine x, h is x times dx. This is a du. So therefore, this is going to be integral 1 over u, and then sine x dx, that's a du. And then we know what happened, 1 over u, it is going to be ln u, correct? Because it's u, you're not going to do, this is undefined, so it's going to be ln absolute value u plus c, and then u, we're going to go back. Cos x hx plus c. Okay, so you can find out that answer. Okay, so think about it. Okay, ln cos x. Okay, so we got this concept. Okay, so I'm gonna adding this information because it's also, you know, that it's, I'm gonna bring this one. So here, integral. So here, integral. So there's a missing information. We are taking integral secant h second, but integral tangent hx or u dx, it is going to be, we just proved that ln cos x and plus c. That's the answer. Okay, so this is a derivative, but if you take the integral of tangent, it's going to be ln cos x. So we proved that information. Okay. Okay, I hope this is going better and better. Okay, now we're gonna do a couple more examples. So far we practiced how to take the differentiation and integral in terms of the hyperbolic function. And since this concept is very similar to the trigonometric function, I'm going to prove a couple hyperbolic functions identity. So let's take a look at that. So we know cos is this, and then sine h is looks like that. One of the popular trigonometric identity, if you remember long time ago, hopefully not that long, cosine secant x plus sine secant x is 1. This is everybody, proved long time ago. So I want to know, is it really true? If I cos second power, if I, is it true? Cos secant x plus sine h secant x is also 1? I don't know. So let's check it out. That's what I want to do. Since in trigonometric identity, cosine secant x plus the sine secant x is 1, so it's going to be same, question mark, question mark, question mark. So we're going to prove. So let's do the work. First, let's cos x. Let's find out the cos x second power, right? That's a cos second power x, the same thing. So we know cos x is e to the x plus e to the negative x over 2. Basically, I'm multiplying same thing twice, isn't it? So let's do all the distributive property. So all the rainbow. So e to the x times e to the x. And then plus e to the x times e to the negative x. Inside e to the negative x times e to the x. E to the negative x times e to the negative x. Over 2 times 2, that is 4. So now I'm going to keep simplifying. E to the x times e to the x, you have the same base. You can adding them up. And then e to the x times plus x minus negative x is 0. And 0, e to the negative 2x over 4. Are you guys following? Yes. So now I'm going to simplify e to the 2x plus e to the 0, that is a 1. 1 plus e to the negative 2x over 4. So again, I can simplify e to the 2x plus 2 plus e to the negative 2x over 4. That is cos x to the second power. We're going to stay here for a second. And then I'm going to find out the sine h second power. So let me change the color. So this one, sine h second. So e to the x minus e to the negative x, you're multiplying subtraction twice. So again, we're going to do all the rainbow. So e to the x times e to the x minus e to the x times e to the negative x minus e to the negative x e to the x. Negative change to positive, e to the negative x e to the negative x minus 4. We good. So that would be e to the 2x minus e to the 0, x minus x is 0, minus again e to the 0, plus e to the negative 2x over 4. Are we okay? So now I'm going to simplify. That is e to the 2x minus 1 plus e to the negative 2x over 4. So what is that? E to the 2x minus 2 plus e to the negative 2x over 4. That's the sine hx second power. So we found out what the cos second and sine second x. Let's adding them up. It's going to be really 1. So we have cos second and sine x second. So let's adding them up. So cos hx second and then sine hx second. So we have e to the 2x plus 2 plus e to the negative 2x over 4. And I'm adding e to the 2x minus 2 plus e to the negative 2x over 4. So they have same for adding them up. E to the 2x plus 2 plus e to the negative 2x plus e to the 2x. What do you guys think? Plus 2, negative 2, yep, they're going to be canceled, right? But then what happened? We have a same number, e to the x, and then e to the negative x, e to the negative x. It's going to be 2 e to the 2x, because we have the same thing, 2, plus 2 e to the negative 2x over 4, which means it's not equal to 1. So we know that sine hx second plus cos x, it's not going to be 1 if you're adding them, right? So this is the addition. Let's try another way. What if I subtract them? So I'm going to I'm going to subtract this, copy, paste. What if I subtract them? What if I subtract? Let's see what happened, right? So we know this information, copy. So this is the cos, right? Cos second, sine h second. Let's subtract them instead of adding them. So because of the negative, the sign, when you're combining the denominator, everything is going to be changing. So e to the x, 2x there, plus 2 plus e to the negative 2x. Because of negative, everything changed the sign. So negative e to the 2x, negative, negative, positive 2, negative e to the negative 2x over 4. So let's observe what you're going to get. E to the x, negative e to the x, they're going to be canceled, correct? E to the negative 2x minus e to, they're same thing, cancel. We have 2 plus 2, 4 over 4. It's 1. So what I'm saying is we prove that when you actually, right, subtract, when you actually subtract, I'm gonna here. When you actually subtract cos second minus the sine, this is the second, we found out that is 1. So therefore, we're gonna make a conclusion. We prove cos x second minus sine h x second, it is 1 instead of adding. So that means I can change the order. That means 1 plus sine h x second, only trigonometric function sine x second plus cosine x second equal to 1. This is in hyperbolic function. Okay, so we prove that, very important, cosine h x second power minus sine h x second power, that is 1. Only trigonometric, if you adding them, sine second, cosine second is 1, so that's a different thing. So that's something, the important identity in terms of the hyperbolic function we just proved, subtract. Okay, so this is adding. So I hope this identity is clear and we're gonna use this a lot, okay? So I'm gonna do a couple just more information in terms of the identity. So let me go down slowly. So I'm gonna, this is the important proof we just got. I'm gonna highlight it, okay? So based on this concept, you could do so many things. I'm gonna go down the next identity. Can you verify sine hx plus y, right, is the same as a sine hx times cos y plus same? I want to prove it, right? So we know sine hx, this is e to the x minus e to the negative x over 2. We know cos h is e to the x plus e to the negative x over 2. So this is a given. We know those are two hyperbolic functions. Is this true? So let's prove the left side. So what is a sine h x plus y? You're going to plugging in x plus y into the x spot. So it is going to be e to the x plus y minus e to the negative x plus y. That's the over 2. This is the sine h x plus y. Is it equal? We know sine x, e to the x minus e to the negative x over 2 times, what is a cosh y? E to the x plus e to the negative x over 2. And then I'm going to cosh x. Oh, actually, this is y because you're going to plugging in here x and y. So this is going to be y minus y. What is a cosh x? Cosh x is going to be e to the x plus e to the negative x over 2. Sine hy, it is going to be, you're going to plugging in y into the sine h, e to the y minus e to the negative y over 2. So I want to prove that they're equal, right? So now I'm going to work on the right side, right? If the right side is equal to the left side, that's your verification. So we're going to do all the rainbow. So here 4. So you're going to do all the rainbow, e to the x, e to the y, plus e to the x, e to the negative y, minus e to the negative x, e to the y, minus e to the negative x, e to the negative y. So that's the first fraction, plus second fraction 4, e to the x, e to the y, minus e to the x, e to the negative y, plus e to the negative x, e to the y, plus e to the negative x, e to the negative y. So let's simplify as much as we can. So what happened? This is the same base. I can adding them up, plus e. We have x minus y minus, we have e to the negative x plus y minus e to the, this is negative x and negative y, plus 4 e to the x plus y, e to the x minus y, e to the negative x plus y, plus e to the negative x negative y. So we are adding all of them. So make a space. So we are adding them. So 4, look at them. E to the x plus y, e to the x plus y, they're same family. And then e to the x minus y, e to the x minus y, they're same family, but they're going to be canceled because the plus minus, they're going to be 0. And then what happened? E to the negative e to the x minus x, these are also going to be canceled, negative and positive 0. And last one, negative e to the positive e to the, they're going to be, actually I have a little bit of typo. This one should be negative though, right? Because when you do multiply this two, it's going to be negative. So my bad, that was negative. So they're anyway combining like term, both negative. So we have, so these are actually cancel. So we have only purple and yellow. So they're going to be e, we have a 2e x plus y, and then we have negative 2e minus x minus y. And I'm going to make it smaller. So over 4. I can simplify everywhere divided by 2 to 2. So e to the x plus y minus e to the negative x negative y over 2. So what happened? Dun, 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 dun. They are same. So we prove that this sentence is true. Oh, these are true verification. We just verified that. Okay, so that's how you are checking hyperbolic identity. So we have very, small amount of the question in terms of the identity. So check it out in quiz 2.9. I'm going to do the last concept in 2.9. What if we have inverse? So if you remember in trigonometric function, we know all 6 trigonometric functions such as a sine, cosine, tangent, cosecant, secant, and cotangent. Same thing is happening in hyperbolic function. So let's take a look at it here. So inverse hyperbolic function. In general, in trigonometric function, sine theta, let's say equal to y. To find out the inverse function, theta will be, we put the inverse y. Do you remember that? So that the x and y, they kind of like switch the order, and then we have an inverse function. Same thing if I have a cosine theta y, theta will be cosine inverse y. So you can find out the inverse function, right? So these are the inverse function of sine and cosine. What if we have a hyperbolic function? So don't worry, everything is a given. Same thing, I do have, let's say, sine h x equal to y, x equal to, you can find out the inverse. What was x originally? So y. So in this time, h and y. Same thing, cosine h x equal to y, you can find out the x, cos inverse y, right? So there are inverse hyperbolic function, by looking at the regular hyperbolic function. So therefore, all you need to do, I want to know how to take the integral and, differentiation in terms of the hyperbolic and inverse hyperbolic function. So here is the table. So you don't need to memorize them. So look at that. So sine h inverse, this is inverse sine, cos, and tangent h. If you are going to take the derivative of sine h inverse, okay, this is the outcome. 1 over radical 1 plus x a second. So this is going to be given. You don't need to memorize it. Again, if you take the integral of this, you're going to go back to the sine h inverse function. D over dx, you're going to take the derivative, cos inverse x. This is the outcome. If you take the integral, you're going to go back to cos inverse. So we're going to utilize this one. Same thing, d over dx tangent h inverse. You have a 1 over, and again, if you take the integral of that form, you will go back to tangent inverse function. Let's say this is x. So we did the similar work in terms of the regular, inverse trigonometric function, I believe in chapter 3. So we're going to utilize this. This is going to be given. You don't need to memorize it. So I will show you a couple examples. So let's take a look at it. So here, okay, I want to take the derivative, the following sine hyperbolic inverse function. Look at them. I have a sine h inverse outside. X over 3 has been subbed. This is a chain rule. So what happened? We are taking the derivative inverse of hyperbolic function, correct? So this is a chain rule because we have to take the outside sine h and inside x over 3. So this is going to be outside. This is going to be inside. So what happened? If you take the derivative of sine hyperbolic, what happened? Look at that. This is the outcome. So we are going to 1 over 1. This is going to be, so we know d over dx sine inverse h. It is a 1 over radical 1 plus x a second. So therefore this one, 1 over radical 1 plus x over 3 second. And then this is going to be just a 1 over 3. And then we can simplify, as much as you can. So this is going to be 1 over radical 1 plus x a second over 9. And then we have a 1 over 3. I can find out the common factor inside here. here, I'm gonna factor out 1/9 times 9 plus x second 1/3. Again, you can separate it 1/9, 9 plus x second 1/3. Uh-oh, I need a space, so let me minimize it. Oopsie. If I minimize it, what happened? This is 1/9 with the radical. This is gonna be 1/3. 9 plus x second 1/3. So what happened? 1/3 bottom top cancel. We have 1/9 plus x second. That's the final answer. So this is the derivative of the following sine h inverse of x/3. Okay, nothing is special. The given table, you're gonna utilize it, and you can take the derivative or integral simply. All right, so one more question. I have a structure. Outside is a quadratic. Tangent, inverse, hyperbolic x has been sub. So another chain rule. So outside, what is it? Tangent hyperbolic, second power. Inside, oh, actually, yeah, it's a quadratic, and inside is only tangent hyperbolic. So this one is going to be what? 2 tangent inverse x, and then times, what is that? Sine inverse, go up. If you take derivative, it's going to be 1/x second. So there is x, so we don't need to change anything, 1 plus x second. So the answer, 2 tangent inverse h over 1 plus x second, simple. Okay, so you can take the differentiation of the inverse of a hyperbolic function. Now, what we're going to do, the following question, we're going to do integral, right? Inverse of hyperbolic function, the backward. So the first example I show you the derivative of the inverse of a hyperbolic. Now we're going to take the integral of the inverse of hyperbolic. So we don't need to scare anything. So we can look at that, the following two examples. I'm going to just do the first one. So what do you guys think? This one, I can simplify 1/4x. It's the same as a 2x to the second minus 1. And then we have a dx. So look at that x. This is kind of like a u second. You can say u equal to 2x. And then you can take the integral derivative. So du over dx equal to 2. Du will be 2 dx. And then if I divide it by 2, du over 2 is a dx. So what happened? 1/radical u second minus 1. And dx is a 1/2 du. And we are taking the integral. I can bring 1/2 to the front. 1/radical u second minus 1 du. We are taking the integral of this form. So let's look at the table. Go up. Radical u second power minus 1, which is this. They're going to be quotient inverse. So therefore, this is 1/2 cosh hyperbolic inverse u plus c. You can go back to the x variable. Cosh hyperbolic inverse u was 2x plus c. So you can take the integral of the inverse of a hyperbolic function as well. Okay, so the second question is the same type of question. You're going to modify a little bit and then find out the u substitution, and you can simplify by using the inverse table. Okay, so take a look at, try this one yourself. If you don't know, always you can post that question into the discussion board, and then we can work together. But I want you to actually try it first. Okay. All right. So in this video, we talk about, hyperbolic function, their definition, characteristic, identity, and inverse hyperbolic function. Let's take a look at one last example in what is a real problem and where you are actually using the hyperbolic function more. So let's look at example 6. So let me read it slowly. So assume a hanging cable has the shape 10 cosh x over 10 between negative 15 and 15 for x, where x is a measure in feet. Determine the length of cable in feet. So I'm just thinking about it. Let's say if I graph it, so let's say this is the function that is given 10, I don't know, maybe here. So f of x equal to 10 times cosh x over 10. This is the cable function. And then they want to find out, length of the cable. This cable, it's not like, you know, it could be linear, it could be curved. So we are looking for actually arc length between negative 15, 15, which is we are looking for this length of the cable. And the cable function is a cosh, it's not linear, it's a curvy function. So do you remember how to find out the arc length formula? The arc length, in this time we are looking for lengths of cable. And the formula, if you remember, from A to B, radical 1 plus f of x second power dx. This is the formula of the arc length. And then we have all the information. We have f of x equal to 10 cosh x over 10. And then actually there's a, you know, the prime and second power. I'm going to take the derivative. So d over dx, 10 cosh x over 10. So that would be 10 times cosh. We have d over dx cosh x over 10. And then you see that this is a two structure going. One is a quotient function, and then x over 10 has been sub chain rule. So therefore, we have a 10 outside cosh x over 10. Inside, let me minimize it a little bit. And then inside d over dx x over 10. Right? So this is outside, inside. So if you work this, we have a 10. Cosh is going to be sine h, x over 10. X over 10 will be 1 over 10. So 10, 10, they're cancel. We have sine h, x over 10. And then we are not done yet. We have to take the integral. We just found out this part. So I'm going to go down. So we're going to do arc length from negative 15 to 15, radical 1 plus, and then we found out this information is sine hx over 10. So I'm going to plugging in. Oh, actually, my bad. This is only sine derivative, right? So this is f prime x. So we have to plugging in sine h x over 10, and then second power, and then take the dx. Okay, continue. So negative 15, 15. And do you remember? Note, we proved that, what is that? Cosh second hx minus sine second hx. We just proved that. What is that? That is 1. So therefore, you can say cosh second hx is the same as 1 plus sine second hx, correct? So therefore, this is going to be equal with the radical cosh x over 10 second power. Am I correct? Because of that identity. And then what happened? Radical second power will be canceled. Negative 15, positive 15. So we have a cosh x over 10 dx. Yeah. And then we are going to take the integral. So cosh, right? You're going to have sine h, and a little bit of note here too. when you take the integral, if you remember, cosh x, it's going to be sine hx. What if I have a cosh nx? Same thing like a cosine. 1 over n sine hx. So because of that reason, this is going to be sine h x over 10. And then that 1 over n, there's a constant. This is 1 over 10 times x. This is n. You're going to flip over. You're going to multiply 10 outside right there. Am I correct? And then you're going to take the integral, negative 15, positive 15. So remember, you are going to take the integral cosh x over 10, but this is the nx form. So there is a 1 over 10 times x. 1 over 10 has been flipped, which is a 10. And then you keep the sine hx over 10. So therefore, what happened? This is going to be, right? Oh, we actually already took the integral. So my bad. So there's no integral anymore. And then from negative 15 to positive 15. So we're done. I'm going to bring 10 here. 10 sine 15 over 10 minus 10 sine negative 15 over 10. You're going to subtract this, right? So this is capital 15, capital negative 15. So this is a little bit complicated fraction. You can use decimal. You should get about 42.586 feet. So this is the cable length as by using the arc length formula. So this is one of the application problem where you're using not only arc length formula, also where the inverse or cosh hyperbolic function has been involved. Okay, so beautifully we are done 2.9. So you might need to take a time to review and then solve each question on your own. That's something you need to follow up. Definitely, my lecture note will be helpful. So I want you guys, download the empty PowerPoint and then just try to solve everything without looking my lecture notes. So that's how you're going to study and practice more and more. If you need more practice, we have a textbook embedded. There's more problems and quizzes, question, and watch more embedded video. You can practice more if you need, definitely. So that's your assignment. So feel free to email me if you have any question. And we do have a discussion board. Always there is a place you can engage with other people. So keep going, keep moving forward. I will see you in the next video. Thank you, everyone. Bye-bye.